So welcome to my talk, Redesigning Legacy Systems, Keys to Success. I see keys to a lot of things on talks these days, but I actually came up with this independently, at least I think I did. And I work for Bloomberg, and we're hiring. So come see someone in Bloomberg if you'd like a change of pace. And I am a senior software engineer / architect in Bloomberg. All right. This talk, by the way, is not about my time in Bloomberg. It's about my time in the industry, which is 30-something years. Bloomberg was a bit antsy about pointing out mistakes and that might be associated with those mistakes, but it's not. It's like I've been a consultant for 20 years before I joined Bloomberg, and I've been in a lot of different companies, seen a lot of different stuff, right? So I think I've seen a lot of stuff that works and a lot of stuff that doesn't work. So where will we be going with this talk, just so everybody's on the page? This talk will be about delivering a redesigned legacy system. Just redesigning a legacy system, I would say, is probably the easy part, right? It's actually getting that to fruition and getting into production and having that work realized is the hard part. So that's what we're going to be doing today. This talk is for smaller system rewrites. And what I mean by that, it's for if you're a single person or you're a team. It is not, you notice I don't have enterprise in the talk or in my talk description, because that's a completely different talk, and I'm living that nightmare right now. I'll probably put a talk together about it in the future. This talk is in two main parts. The first part will be principles to follow. Some might call it theory, but it's all backed up with hard-won experience. And then the second part of this talk will be a case study from the real world. And I'm not going to say where in the real world, right, to protect the innocent and the guilty. So if you have questions, please note the slide number in the bottom corner. I gave a talk 2 days ago on managing APIs in enterprise systems, and no one gave me a page number when they asked me a question. I had to feel around for where I was. So what is a legacy system? Well, I think it's in the Oxford English Dictionary. It has a really good description of denoting or relating to software or hardware that has been superseded, but is difficult to replace because of its wide use. And I think that's an excellent definition. However, I'm going to simplify that to be just the current software in production use. Now, I've said to people who have a system in 2 years, and I go, yeah, that's a legacy system. Look, this is brand new. We've just put it in a year or two ago, and we're still moving clients over. It's like, yes, there's a legacy clock has started on your system, and you are not as free to make changes and cause problems as when it was pre-production. What is a system? A system seems to be self-referential. I got this from Wikipedia. A system is essentially a system or a subsystem, right? It's kind of confusing. For me, it's just some intercommunicating components that form part of a larger system. They might be part of an enterprise system, but it's not the whole system. All right, and that set of intercommunicating components could just be one, right, where someone communicates with you out the other side. So again, this is leaning towards this small scale rewrite. So the question you have to ask is, do we do a full or partial rewrite when we have problems in the system? And I define a partial rewrite as you've identified some part of the system that's given you problems, and because of that, you don't need to know the overall system. You can concentrate on one piece of it, like I'm changing out the database. I only have to know how the database interaction with the system works. I don't have to know about a bunch of other pieces of it. I put porting in partial rewrite, whether you're porting to a new architecture like Linux, or you're porting from old to modern C++, you don't really have to know too much about the system, right? You just have to know the places that break. So here's where we start the journey. So for whatever the reason, and there can be multiple reasons, see an earlier version of this, I did a slide of all the reasons you might rewrite, but somehow you've convinced management that we need a rewrite. So what do? At the very start, we're very enthusiastic, we've got all these lofty goals, you think the production system is pure crap, and anything I would put in there would be miles better. And because you don't accurately define the problem or go look to see what the data behind that problems are, you make unrealistic deadlines. Hey, I need 12 months, and you just probably pull that out of thin air. Management says I can only give you 6. Sure, I'll give it in 6 months. Right? Not a really good way to go. The next thing you do is you make a sort of proof of concept or something that's more like a hello world. And it works really well, right? Because you have not tried to interact with what I'll call the real world yet. And this is what I would call the honeymoon phase of a project. In other words, the deliverables are way down the line. Going into production and you're so confident because you don't understand the problem yet, right? And you're like, time is not really passing. You'll take months of doing this and then find out, wow, the real problems are something I didn't anticipate, and I found out further down the road. So I'm going to move into the middle phase of the project, and that's where I get real world trouble. So I've taken my simple proof of concept, and I now say, this should model some part of the system pretty exactly. And that's when you run into all kinds of corner cases, all kind of arbitrariness, all kind of stuff that made the original production code very messy. And you get scope creep. So you thought, oh, it's going to be a 6 months project. But once you actually got in there and tried to do a real world representation of some part of the system, you realize you underestimated the complexity of what you're doing. There's a lot of stuff that was buried in there, and it's hard-won experience. Probably 20 years of problem reports have gone in there to make this thing correct. And this is an implicit scope creep. There is an explicit scope creep where management or business will say, look, seeing as you're doing a rewrite, could you put this other chunk of functionality in that the users are begging for? And we can't do it in the legacy system because it's so hard to implement. Yeah, sure, why not, right? That's scope creep, and scope creep will kill you on delivering a project. So here I am now, I'm getting towards the latter piece of the project. I'm starting to miss deadlines. I hope you have a bunch of deliverables or milestones in the project, not just I'll deliver half it in 6 months and the other half in a year, because your resolution of when things are going wrong is going to be got a huge time lag in it. But now we're getting into the end where there's pressure to put this thing in production, right? We have a lot of pressure from management, pressure from users, pressure from business, and we start hacking the design, and we start loading in tech debt because we're going to do this for now so we can get by a couple of problems. This is what happened in the real world system that you're trying to replace, right? And you thought you would be immune to these kind of things, but it doesn't happen. And someone comes, well, where are you? What's our progress on this? How close are we to delivering? And you're like, well, I don't know. We're so busy fighting fires and trying to get this thing out in production. I really don't know where I am, but I'll deliver it next month, right? You don't know. You're just saying that. You're hoping that's enough time. And then you maybe miss the deadlines again. Or if you don't, you give something that's pretty buggy, loaded with tech debt, doesn't have the reliability, and maybe even less efficient than the original system. All right? And then you got to ask, is my project a failure? And you can ask that, but it's worse if your managers are asking this. And you can sometimes beg for mercy and say, listen, put me back over to the hack and the design, like the bottom part of this chart, and I'll hack the design some more. I won't really know where I am. I'm just sort of trying to get to the end. I'm not sure where the end is. And if I keep missing deadlines, the project will be termed a failure. So how would we get onto a better track? Or how would we have some principles, goals, something that you may not be able to do exactly, but if you get closer to this, it will give you a better chance of success. And that's really what we're trying to do, maximize our chance of success. So what are the key ingredients I will need? I mean, I do a bit of baking, and when I go to bake a cake, I make sure I have a recipe and the ingredients. I don't just throw flour in a bowl and see where I'm going from there on in. So when I go to redesign or replace a legacy system or a piece of a legacy system, I have to say to myself, is there problems that will go away when this rolls out? An observable measure of success, not I don't have to get a technical guy and show him the code. Everybody can see it. If I don't have that, I may have to back off to metrics and say, well, I mean, in the case I use transactional systems, so the current system does 50 transactions a second, I'll get it up to 500. If you're saying that to me, I'll say, where did you get 500 from and why is that such a great number? It sounds very roundy. And they'll say, well, it would be great if we had 500, so that's what we're going for. But you haven't properly defined what success is. And the real people that should be saying this is your users or your stakeholders, right? Your clients. The other thing you need before you start is some knowledge composition. And what I mean by that is I need some historical system knowledge. And I need that so I can figure out how to disentangle what's going on in the current system, provide context on some kind of strange code. I'm like, why would anyone ever do that? They'll say, well, here's why, and maybe it's a good reason. I just was ignorant of some of the constraints they're working under. And they'll also say, well, here's where the current pain points are. I've been on the system 10 years, and this has always been a problem. Now, if you're a team of one, you have to go out and ask people questions and get this yourself, right? Which is doable. The next thing you need, I believe, is design architectural experience. I have seen in many projects, it's just whoever's free, or whatever group is not doing the most, is giving the job of architecting a system, which I think is the wrong way around. I think you find the guys who are delivering systems and delivering proven deliverers of change and use them as a seed in a group. All right? So they should have a proven track record, should be seasoned. And by that I mean they haven't lived in this system their whole life. They didn't come out of college, go into this system, and they've only seen this system for 20 years, because then they can't think outside that box. It's very hard to think outside that box. And one of the other things I think you need is new blood or creativity. I like to have some younger dudes who say, listen, here's all the new technology, here's new ways of doing stuff. They're very enthusiastic. And you have a side benefit that if you run them through this track I'm going to show you now, they'll learn how to do things in a structured way, and hopefully that will flower out as they get older and become system managers or leads of technical leads, okay? That's a side benefit. Now, as developers and very technical people, we hit this last point, which is the business or market buy-in. Like, man, it sucks having to talk to these guys. They don't know, about template lambdas and stuff like this. But really, you need buy-in because during the project, you suffer periods where your project can get killed off or resource starved. And unless you have the visibility, that's what happens. The other way you can do this is you can do it as a side project, right? I've done stuff like this as a side project. I'll say to my company, every Friday afternoon, don't bug me unless there's a production problem, because I'm going to work on something I think needs to be worked on in the system. So that's the knowledge composition. And just one note on the historical, right? There was a Spanish philosopher, George Santayana, who said those who don't look at history are bound to repeat it, or something like that, right? And I think those who are stuck in the past are bound to repeat it as well. And that's why you need people who have not been on that project a long time. So moving on. The next key is requirements. All right, and how do we know what the requirements of our system are going to be? Well, we need to analyze the data flows. We need to see how traffic moves through the system. And I'm going to lean here on transactional-based systems because this is where I'm from. This is what I've done for a long time. I mean, I think this could probably be somewhat mutated into, you're rendering graphics or something. But what I need out of my system, my legacy system, is qualitative and quantitative intelligence. Right? I need to see what's actually going on in the real system as opposed to just assuming it needs something done. So I'll look at the peak loads. I'll look at the long latencies in the system. I'll look at what's affecting throughput. And maybe it's some type of input that's causing the delays. So the input composition is also important to look at. Once you look at this, you now have hard data of what's going on in your system. And now you can confirm your intuition, uncover misconceptions you may have had. Right? I've always found in transactional systems, the largest volumes are usually the simplest to handle. Because they're simple, many people do them, so there's lots of them. You can also apply your own measurements or tests to what's the value of your system as you start building it up. And you should be able to validate the pain points that maybe your historical long-time maintainer tells you. But he might tell you something, this is a pain point, and it was fixed 3 years ago, we just didn't know about it, right? Some other team did it. So you have to validate this information. Once you have this, you can now hypothesize outcomes. If I do this, what's likely to happen with this type of traffic? You can then innovate and implement your design. This is when you start designing, when you know how the system has data flowing through it, right? You can now map strategic goals. How am I going to tackle this problem? What kind of phases am I going to do it? So tackle it in focus and in time. And I always say it's very frustrating when I've seen projects that they just launch into a rewrite without looking at how data is going through the current system. It is the most underused design asset. And you can base your design on evidence, right? And that's crucial. I had a project I was working on, and they were doing a rewrite, actually, of a much bigger system. And I said to them, what's going on in your system? What's the data composition like? Oh, we're going this way. This is what we think. And I went, why is no one looking at the data? And I campaigned. Some would say I complained bitterly. And they eventually came on board with that. And once they came on board with that, they actually sprouted off a new project called Business Intelligence, which was to look at that data to figure out, because the large enterprise system has years of migration, to figure out what the migration strategy should be based on the current snapshot of the system, which I thought was very intelligent. I was tickled pink that it was finally got through. So now I have information. I know how things work. And I always say the key to system design is design over technology. What do I mean? You produce your design first, and you put your implementation technologies in later. I have seen far too many PowerPoint presentations, that's probably something else these days, which has just every buzzword that you can put on a slide, and nothing about how we're actually going to have the flow through. We're going to be using, I don't know, coroutine, or C++17, and coroutines, and I don't know, other stuff that's wafting around the office. It's really the bad way to go. Design is, I would say, to a large degree, technology agnostic. I'm pretty sure most of the systems I've worked in, I could use most any database. I could use most any broadcast mechanism. Now, if we're set up for some particular technology, then I'll try and use it. The inclination, though, is to believe technology will solve our problems. And if you have systemic problems, that's unlikely. And I'm going to show you some proof of that later on. And then the last thing is you have to avoid mimicking the legacy design. And this becomes a real problem if the people who have been on this project for a long time are told, go redesign the system. They find it very hard to think in different ways, and that's why you need someone who's seasoned and seen a lot of different systems, right? So let me show you. Here is a flowchart of data going through a system. It's close to the one we're going to be using as a case study. And as you see, we have something coming in through the fixed protocol from external. We don't have any control on that. We have a pre-processed task, and it takes that thing and puts it into our own format, right, our own structure. That's pushed on to enrichment, and enrichment will say, oh, you know, what is this user's permissions? What is the security information? What is a whole bunch, who's the delegates that can alter this trade? So enrichment happens here, and it usually goes out to other services. It's not database driven. And then we go to core handling, where we actually we have loaded up the state, and we are going to say we're going to do some transaction. The state will change. We'll save that back to Sybase, so we have persistence. And now we'll send it out through TIB, which was the Technicron Information Bus. I don't even know if that's around still anymore. You might know, Michael. No. All right, and we have T listeners, but you could just subscribe, and your terminal would show updates. So they decided to re-architect the system, and this is what they came up with. Right? So let me show you that again. All right, it's kind of subtle. They put new in front of everything. That was the first thing they did. And then they said, okay, instead of us using this TCP, a handwritten layer, we'll use MQ. Give us some more fault tolerance and stuff. Okay, but I don't think that was the problem. All right, and then I have Cassandra. Now, you see the difference here is I need a bigger cylinder, right? So it's got to be better. All right, and then I have Kafka and K-listeners and stuff, right? But my point here is that they mimicked the legacy design because they couldn't really see outside of it. All right, and that's the real danger. Now, if you're doing a port, this is fine. I'm just going to change the database from Sybase to Cassandra. That's fine. You leave the rest of it as it is, and you work on this piece you're interested in. So underlying technology replacement is usually not the answer, and I'll qualify that a little later on. And using the latest technology is nice, right? Certainly good for your resume. But you leave it to the end of the design process. It has no place at the very start of your design. Unfortunately, buzzwords, unrealistic expectations are the norm, and that's how a lot of projects get lifted off the ground, and that's why we have such a terrible statistic for success when we're doing rewrites or re-implementations of technology. Okay. Let me give you an aside about new technologies because we do so badly in this thing. They're easy to introduce, but hell to live with. All right? There was a guy, Dan McKinley, who wrote an article which was Use Boring Technologies. Very good article. And what he more or less said is, look, when you use something new, you don't know how mature that product is, or if it's going to undergo seismic shifts because it's so early in its development. You also, what production level integration do you have with this new technology? Is your current maintenance crew going to know about it, or is it just going to get dumped on you? And believe me, you do not want the second one. And new technologies don't advertise problems, only benefits, right? I interviewed a guy a month and a half ago, and he said, I'm a big Python expert, done all kinds of stuff. So do you know about the global interpreter lock? Who here knows about the global interpreter lock? I would expect this crowd to know. It's something that stops you running Python code in parallel, right? And he didn't know about it, and he had wrote a lot of Python, right? Yeah, I know, you're very savvy individuals,
so what
right?
Final word, global interpreter, and then the final word?
Lock.
Okay.
So it's a mutex, and it's global, right? All things we don't like to hear in the C++ world, right? So you don't know what the unknowns are, and you'll find the cons only when you start using it. Now, the old technology, you know where it's terrible. You have a pretty good idea of the stuff that's wrong, but you know it, right? So you can maybe budget more or allow for it. And I always say, can you do this? Ask, can I use current known implementation technologies in my new design? Do I really need to take every technology and change it? I say you change the worst of them. I'm not a Luddite. I don't think you stay with everything that's there. But I don't think that you need to change absolutely everything, right? Because that's going to give you more risk, and when you go to production, more problems. The next key, something else I think we do relatively badly, but there's a lot of project managers who have nice charts and stuff, is the project has to be staged with deliverables and milestones. I need a roadmap. I'm going on a journey. I may not know the distance, but I know where there's signs on the road I have to pass. So a deliverable is a measurable and tangible outcome of the project. It means I can show it, I can taste it, I can feel it. It doesn't mean, hey, you don't know this, but there's really fancy stuff going on underneath the hood, and that's great. That's not a deliverable. Milestones are a collection of deliverables, and they show that we have reached some notable point in the project. We've hit some part of the project which is significant because we've changed something. And then tasks are what are inside your deliverables. I call them the pieces, the JIRA items if you're in a Scrum setting. And what these do is they give you the resolution of your timeline. So how long should your tasks be? Pretty short, but we'll go into that. They should be attainable and they should be realistic. That's a judgment call, right? And maybe personality, right? Some people like to say yes. But you should be realistic. They should be observable outputs, right? In other words, my deliverables are easily seen what's going on. I've added functionality. Look, when I load this thing up and you're on the front, you don't see any problem. And on the old system, look what would happen. And what I call chartable. In other words, we have a lot of them, right? So I don't go, yeah, I'll deliver you, like I say, half it in 6 months and half it in a year. Because the final prod deliverable without a bunch of milestones of deliverable is almost useless. And you can't really talk to your stakeholders very well when you don't know where you are on a timeline. And this is the thing I say a lot. It's not mine. I heard it somewhere else, and I've taken it and made it almost my own. Functionality and code metrics over feeling. How am I doing? I feel we're doing great. I think things are swimming. It's like, yeah, pull me out your roadmap of milestones and deliverables. Show me where you are on it. Show me your current set of your next 2 sprints, and show me that you're where that is on here. Now I'll believe that you're feeling good if everything checks out. But just that sort of, I feel it in, kind of feel it in the wind that things are going my way, doesn't work. So functionality and code metrics over feelings. Now, the key to moving forwards. So I'm writing code right now. Okay, I have a design, I start implementing it. What do I want to do? Well, quality is the result of consistent incremental improvement. One of my old bosses said that to me. I don't know if he had it or it was somewhere else, but it's true. You have to keep the quality in your implementation of the design. You have to realize iteration will approach perfection in a far saner manner than trying to spec perfection out at the start. Right? Am I doing good enough? You've got to be aware of scope creep. If you have done the original analysis and you've put a chart of what we're going to do, that should be pretty tightly defined. And if someone comes along and says, hey, I need you to do something else, increase the scope, I'll say no. That's my first sort of instinctive reaction. And if I'm forced to do it, it's like, well, let me go back to my roadmap and see how bad it bends it out of shape. But it's not for free. Small tasks that, we set these things and we say, you do this, you do this, you do this. The task should be small, right? Roughly, I think 2 to 3 days is the best. To start overflowing these time boundaries, who's been here where you're given a task or someone in your group's given a task and it's like, yeah, this is 2 days. A week later, they're still telling you, yeah, it's much more complicated. Are we near the end? No, I know, I'm still diving into it. Right there, you showed you misestimated the problem, right? This thing now should become a spike. You should sit down and say, now that you've looked at this, what are the set of maybe parallel or serially interdependent tasks that this takes? You need to break it down further so you have a resolution on the problem of a couple of days so you can spot the problems faster. I say this a lot. I've said it in many other talks. The real world is messy. Your nice, clean design is going to come under pressure to be hacked, to bend out of shape. You have to struggle, and I mean sometimes it's a struggle, to stay to your design goals and overall vision. Because in the real world, where the legacy system lives, it's kind of succumbed to this, right? No, anyone out there who's working on a legacy system, I'm just saying how I think it is. But what are you going to do? Well, if the current design has a terminal mismatch with reality, then your design must evolve. You do not use tricks to hide reality. I was on a project and they had a transactional system where you had orders, suborders, and stuff like this. And they said the entity at the top looks down, but nothing ever looks back up, right? It's a real lovely concept. And we had even checkers in the code to make sure that didn't happen. And I sort of sat down and showed a sort of mathematical proof of this would not work, because when you change a suborder, stuff in the main order has to change. And the next reaction was, how do we bury this? How do we fool the checker? Using type erasure or something like this. I was like, no, we map to reality. And we did. I eventually won that argument. And once we started doing this idea of there were exceptions to it, we had a whole bunch of problems in our state machine modeling that went away, right? So you have to evolve when I say you have a terminal mismatch with reality. These slides have something on the bottom, which is kind of the whole theme of what's going on above. 1 minute remaining. Oh, okay. Whew. Sound way behind. All right, getting back to the talk. So we maintain quality through testing. So as you are building out the new system, you must put testing on it. And not just unit testing. I have come across, and really a lot lately, where I say, this part of our system is not functionally tested as on the system level. That's okay. We have tons and tons of unit tests, which is great. But a unit test, by definition, will not check out how the whole system interacts with each other. And it seems to be something, I don't know, we're not teaching and we're not telling people, but I hear it a lot. System testing is not replaced by unit testing. All right. So I'm trying to deliver product. I have my nice task. People are going. Let's go, let's go. The key to productivity, which I call delivering product here, is shortening feedback loops. A long feedback loop is what will kill progress in your system. And given iteration is the key to delivering a working system. I hope I've convinced you of that. How do we identify and shorten the feedback loops? Because that's going to give us better delivery. So where are these loops? Well, you have combination and linking. You do something wrong, you're told pretty quickly, fix it. You have unit testing to say that you're doing things correctly. Code reviews to say you're doing it in a sane manner. Automated system integration, I hope it's automated, right? System integration test and see how the whole thing works together. We have things like development process reviews, like sprint retros, which are trying to tighten up your process so your whole way of delivering is better. We have alarms, meaning we have alarms on production when they go off. We have to fix stuff. We have QA. Most large places will have their own QA so that some independent testers are running tests on the code, not just you, who have an intimate knowledge. Dashboards and metrics, a lot better these days. We were terrible in the past with this. We can see this current system health. And then we have internal users and early adopters. All right. Now, I'm just going to boil, and then we have real production usage, right, where people say real men test in production, right? No, that's very visible, and you're under a lot of time pressure, and you will hack changes when you're under that kind of pressure. So again, I'm going to take these and just boil them down to the one I'm really interested in. So unit testing probably gives you feedback in a minute. It depends, a couple of minutes, right? Automated integration testing, 15 minutes to an hour, something like that. QA, where I am, well, where I used to be, was like a week. So they would check this thing every week, and then if it was wrong, you fixed it, and they checked it the next week, and if that was right, then it went. So you got 2-week delays, all right? Alarms are whenever, and production usage are whenever. But the thing to realize here is, if you skip one of these, so let's say I say, you know what, integration testing is not something I'm interested in, it's too hard, it's horrible. Well, what happens is, it migrates upwards, or here, actually downwards here. It migrates down to QA. And now I have weak lags of, did I fix the problem? All right. So what you want to do is make sure that you have not just these in place, but if QA finds a problem that I missed in my integration and unit testing, I want to put a test in there that now catches that. If I can catch in the unit testing, that's great, because my my feedback loop is almost instant. All right? So that's what I want to do. I had some other point, but I kind of can't think of it at the moment. We'll just have to move on. All right, so the next thing is, what about understanding your system health, right? Or what we call these days SRE, or building in observability. And I think what's going on these days with observability is kind of where unit testing was maybe 10 years ago, kind of an optional extra. You know, if you're highly intellectual, you indulge in unit testing. But these days it's seen as vital, right? No large system really doesn't use it. So what do we do in our observability? Well, things we've done traditionally pretty well is alarm on bad hours. Now, bad hours are surprisingly tricky to define because it's when intentions are not met. It's not when your system sends an error back to the user. The user tries to withdraw, I don't know, $100 out of his bank account, and he's only got 50 in it, and I say that's an error. That's not an error. That's the system properly handling something, okay? So when the intentions are not met, or, you know, I give him the 100, that would be a bad error. We also have things where we check processes are down, multiple restarts, something's frozen, we'll have some heartbeat. Or some of the dependencies, when I come up, I know I need to be able to talk to this service, and one of them's unreachable. So these are the things we do pretty well. The things we don't do so well is meaningful metrics. What do I mean by that? Well, if I'm in a system and there's some part of it where, I don't know, if the database is out of whack or something, I'll retry. or there's some kind of repeat loops in my system. All right, when do these retries per minute start cresting? Do I know about it? In a transactional system, has the request latency started going upwards? And it won't be like one request took a long time. You don't alarm on that. It will be the average request over a particular window of time has creeped up. Also, how is the saturation of my system? If I have input queues, all right, how heavily are they being used? What's the CPU doing? Am I coming close to saturation? If I am, there's probably a rogue process out there, internal or external. I want to take it down before it takes me down. So these are good things to have. Oh, and the other thing about these is I say alarm on them because you have metrics and dashboards where you can go in and look at how things have been going all day, what I call eyes on glass. That doesn't work because someone has to be sitting looking at the metric when it's going bad. So an alarm lets you know. I think it's like you're driving in a car and I have no dashboard. Right? I don't know how fast I'm going. I'm not sure if the engine's overheating, if there's oil in it. I can't remember when I last serviced the car. And really my only clue that something is wrong is, I don't know, a policeman pulls me over for speeding, my engine blows up. All right? I'd much rather have a dash and a light on the dash that's blinking, hey, you need to pull over, your engine's going to explode. But the other question I get asked is, depending on the scale of this, do we need this for smaller rewrites? It's a small part of the system, and it's easy to go, yes, yes, always do it. I'm over here in my ivory tower. I said everybody has to do this all the time. But that's really not the case. If you're doing a smaller rewrite and someone has metrics on you, then it's okay. All right? Because when you start going out of whack, the overall system says, hey, this piece of the system is going out, and they come to you. Now, this is the thing I think doesn't go so well a lot of times is the successful rollout. Because up until now, everything you've done is potentially useful. Until it goes into production, you don't realize the usefulness or value of what you've just done. Right? If I bring it right up to production and I don't deliver it, that was all wasted work. Right? And you don't get the credit, no one else gets the value. It's just a bad scene. So when we want to move new users, and like I say, I'm leaning on where I've sort of the space I've been in, how do we move new users from an old system to a new system? All right. You can do it by functionality or by entity or client. But what I have to ask is, where is the tail on this project and who's going to be sitting on it? In other words, this project is not going to instantaneously, well, it won't where I do my work. You can't just say everyone over tomorrow. Forget about the old system. You can't do that, right? We don't have that kind of risk profile. So who's going to be on the later end of this migration? Well, if I partition by functionality, I'll be able to pull large clients over because remember, the biggest amount of trades is the simpler stuff. But if I do it by client, a large client will generally have some smaller business of very tricky stuff, right? Splits, derivatives, all this kind of stuff. And to me, for me to take that on board will kill my timeline. And I won't be able to show something sooner and build some, I don't know, political capital to say, look, I delivered a large slice of functionality. Now I'll do the more difficult stuff. So if you have a large client and he's sitting at the back of your move process, so he's on the tail because he's got a large, like I say, a large diversity in what he's doing, he's not happy. And as I heard one business analyst say, no one is celebrating moving an important client to the redesigned product 5 years after it was first rolled out. There's not so much a celebration as a kind of grunt of pain. And people don't want to remember what went on. It's like let's all try and collectively forget that. Right. A large project I was on that was doing a rewrite, we're running into this problem. And I was saying, look, we got to pull them over by functionality, not by client. And they actually split the difference. What they did is said, large clients are going to be logical clients. Like there's going to be a collection of logical clients that make up this one enterprise. And we're going to take the people who do all the simple, vast volume of trades and put them on the new system and leave the other logical client, which is the really tricky guys, on the old system. Smart. One thing I will also say, don't know if you want to tell this to the people that are stakeholders, but do not backport new system benefits to the old system if you can help it, right? Sometimes what will happen is people will go, I'll get you in a second. People will go, oh man, you've just got something fabulous here. In the demos, this just looks great. Can we maybe, you're going to be delivering this in what, 6 months? You got 3 months left to go. Can we maybe just pause what you're doing here, take a month out of, and put it in the new system? If you say yes, you're dead, right? Because the old system is not well tested, is not easily grafting change in on it, and you take dazzle off the new system. People won't say, well, why should I move? One of the important things are in the old system. So that's just a sort of insider tip, right? So now let's go back to our original progression. And let's see if we can get on a safer path or one that gives us, oh, sorry, I forgot about you.
In your partition by function, I noticed you mainly talked about starting easy. What has been your experience starting with complex?
No, I'm usually in complex systems.
Your most complex clients and use cases first before the easier ones.
Okay, so the question was, what happens with complex trades and complex, operations by a client when I try to partition by function? Is that the question?
Like starting with a long tail of functionality, people who use your system in weird, niche, unexpected ways you had to design for.
Right.
Versus starting with the subsection of your clients who tend to stay more on the old beaten path of functionality.
Right, so that's where I say, right, we go by functionality, because even the people that are, a lot of times, complicated trades have been done by big entities, but they're small, right? Even though they're probably a vital part of the business, the vast majority will be done simply. And what I'm going to do is pull them over and leave, even if I leave a small section of that company on the long tail, they're going to be saying, look, my desks over here are using your new system and it's great. When can I get my old clients on it? As opposed to, we're stuck with all our business on the old system because I haven't quite got up to the very complex stuff yet. And it's just a better way to move your clients over. And in my experience, that gets the benefits sooner, which means that you're now building up goodwill or you're showing you can actually deliver. And if you need cooperation from other entities, upper management will give it to you. Okay? All right. So now, how can we go, like I say, in a different progression, right, than what I showed you before? So what I'm going to do is have a defined scope, right? So I have made, like, what is my end goal? What problem am I going to solve? All right, so I'm going to have some kind of goal of what we're going to do. And that's going to be backed up by looking at the data, how it flows through the system. And because of that, I'm going to know what I'm going to have to do better or what I'm going to have to take care of. So I can get that chartable list of things I need to do, and I can put more realistic deadlines. All right, because again, it's all backed by data. I have a data-driven design. So now I can start saying, okay, I'm not solving non-problems, which I've seen surprisingly happen in a lot of systems where they say, I really want to, there's a problem over here. And people are like, the business side is like, we don't even care about that. Now you have your point, you have your data-driven design, so you do your proof of concept. But because you have a better appreciation of the problem, because you looked at how the system has data flow through it, because you've charted out the deadlines, right? You should have less of a shock with going to reality. You'll still be under pressure, right? Real world is messy. But you have a better shot of staying on the original design and vision. Especially if someone's seasoned who's like, we're not taking the easy way out, let's all sit and figure out how we can adapt and evolve this into our design. You know to resist scope creep, right? Resistance is not futile, no matter what the Borg tell you, right? Resist scope creep. Scope creep, I think, is one of the biggest killers of project. You didn't properly scope it out, or you're letting scope grab you as you're trying to get this project off the ground. Remember, we have milestones that have been targeted. So we're moving down a path of progression, and we will know if we start slowing down. And when we hit terminal mismatches with reality, we're revolving the design. That can be tough, but it's worth the effort as opposed to just saying like knee jerk. And remember, once this goes into production, you will not be able to make sweeping changes that easily. Is my progress on track? I can tell you if I'm on track. I can tell you if I'm not on track. And I can probably tell you a lot further back with a lot of notice. So, hey, I know I was going to promise this thing in the next quarter, but looking where I am on my progress, I see I'm only 2/3 the way down. I'm going to need probably an extra month, and here's how it fits in. Here's the new plan. All right, but you're letting people know. If you say to someone, yeah, we're going live tomorrow, and tomorrow you say, you know, we just didn't cut it. Right? That's a real bummer when people don't get advance notice of what's going on. And then you have to execute the rollout. And that means you have a rollout plan and a rollout strategy and a schedule that you can show people, this is how I'm going to bring the people over, partition by function. I'm going to turn particular clients on, right? I'll probably have a few canaries, like smaller clients, I don't want to say unimportant, but do less business. You'll put them out or internal users, and once they look good, you'll start bringing over, like I say, the simple trades from the largest clients. And I'm going to back all this up with the actual real world in the second part of the talk. Now I'm asking how successful is my project, not is it failure. All right, I've met goals. Maybe I've done even more than I was asked to do because I seen through my chart I was ahead of progress. So I absorbed a bit of maybe extra functionality that I seen was needed because of my original analysis of the system. So questions? Yes, young lady at the back.
Okay, so maybe antiquated choice of gender terms aside, the Mythical Man Month is one of the Bibles of software engineering, large projects, and it mentions that there are diminishing returns. There's this idea of diminishing returns where you add more people to a project, and there's an ideal number. And I'm curious, in your experience, what the right number of people to have on a project is.
Okay, so the question was, there's a book, The Mythical Man Month, and it talks about when you add team members to a project, the effects it has. In an earlier version of this talk, I have an aside on adding people to a project. That when you get into the last, that last piece of the graph I was showing you, the progression, and you're behind, there can be a knee-jerk reaction of, let me throw people at the project. That's suicidal, right? Because when new programmers come on a project, they are net, they're not contributors. They're a net loss. Over time, they will definitely come up and start being productive. But you have to mentor them. You have to do more code review with them. They need more help to get anything done. So at a critical time of a project where you're in the last throes of getting into production, you're just ready to go to production, and something like this gets dropped on you, it's going to kill your productivity. And I've had personal experience of this in that we had a project that was, I think it was in November, the end of November, said, look, some other areas shut down business, and we're dropping 15 new coders on you. So, we're not expecting the January deadline to move closer, but we are expecting the ones that were out in maybe next June to pull in as well. It ground everything to a stop. It literally froze the project for about 2 months. And I ended up actually having to, how do you mitigate that? You either get the people in at the beginning, which can be tough because you're maybe not proven. All right, that's one way you can do it. Or you can say, look, I'm going to put together a training course that new people have to go through. That's actually what I did in that situation. I put a 10-hour training course together so people could come productive instead of just, learning all the mistakes the hard way. The other thing is, if there is very decoupled piece of work, you can maybe farm it out. You say, here's the specs and what I need. You guys go off and do it and return it to me. But I'll still probably have to write some unit or system tests because I don't trust other people. Bob, you had your hand up first.
So, suppose that you've decided you're rewriting the system as we posited before, and in implementing your design, you're saving in implementing the design that you've decided on, you find that there's some thing that you need to do that's new. You're doing greenfield development, or you're developing a new algorithm or something that is researchy but needs to be done in order to implement your new design. No one has experience doing it, or it's a new technique that hasn't been done before, but your intuition is it will do the job for us.
Okay.
How do you manage tasking with that when you don't really know yet what the tasks are as you're trying to develop that new thing?
Okay, so the question is, what happens if when I'm redesigning a system, I have a new piece of functionality that really is greenfield, and I'm not quite sure how it will work? So what I will say is, in my experience, unless you specifically take on something new, you'll be doing maybe the old thing in a new way.
Okay.
And yeah, there can be some research. I mean, you'll have like some spikes on your sprints, some tasks, right, in those deliverables. Figure out, right, is this the way to do this? Or you'll have a group design meeting, right, the thing we normally do. So a lot of this will actually translate to greenfield development, except for you don't have the data evidence to do your design, right? You have to take a guess at what the market or what your users want. And that's the great thing about redesigning a legacy system. So many people won't see that as great, that you're actually redesigning a legacy system. Does that answer the question? You had a question?
Yeah, my question was about, your talk kind of takes it as a given that you do need to redesign the legacy system. I'm curious if you have any thoughts on when it's necessary to do a full redesign and when you can kind of incrementally refactor given parts of the legacy system rather than replacing it wholesale.
Okay, so the question was, if I'm redesigning a system, give it to me again.
So yeah, the question is,
I was thinking about it and I forgot the original
the
question.
talk kind of takes it as a given that you need to redesign the whole system.
Okay, so that's the decision between whether to do a full rewrite and a port. So the question is, when do you know when to do a full rewrite
This is like
and a
an
port?
incremental refactor on part of it.
I say and I've got surprisingly far with ports. I've been in many systems where they were actually redesigning a new system. And I found parts of the core that were just unmanageable and rewrote it, right? I was actually on one project where they had attempted to rewrite the system. I think it was in Java, and they failed because it couldn't handle the throughput. Then they started a second track of trying to, now they didn't reverse the guys, the few clients they put on the new Java-based system, they went ahead and then got a second way of doing it and didn't reverse the old guys off, the guys who were on that Java off, which is another sin we do, right? Should have backed that whole thing out completely. But as they were designing and coming up with that system, I was hired to keep the old system running. And as part of keeping the old system running, I blocked out some time to look into how the system handled data, what its transaction policies were, and see how the traffic flow. When I looked at the shape of the traffic and what was going in, I went in and changed some very core fundamental pieces, but I had testing wrapped around it, so no one noticed, right? I came across very odd things, right? I had to bring it from, I think it was C++ 95 up to 2000. They had like typedef int bool, and typedef, 1 true, 0 false. I found in some part of the systems they were using the bool with 3 values, 0, 1, and -1. So it was a tri-valued bool. So when I brought them up to the latest compiler where you had a real bool, stuff didn't work. But I went in and touched the sensitive parts of the system. When I went back to senior management, I showed them that I found the slides that were originally presented to say, here's why we need to rewrite the system. And every one of the points had been killed off with the rewrite of the very central piece. But it wasn't a rewrite, it was just looking at where the problems were in a system. And they were in a very tightly defined space. And I showed him that I was outperforming the new system. And he said, well, look, we've put several $1 million into this redesign. Politically, there is no backing out to the system you have, even though I grant you it's working better than our new system. So I think that was a Thursday, Friday. On Monday, he had assigned me to the new system as an architectural lead. Okay. So in the earlier version of this talk, if you look at the ACCU version of this talk, I talk exactly about what sort of decisions make that choice between full or partial. All right. Some of it is subjective. This thing has been around a long time. Some of it is, hey, we have definite problems and we just cannot get by with the architecture of the current system, in which case it needs a rewrite. Anyone else? All right. So here are all the keys here. I'm not going to go through it. It's a lot of text. You can look at them at your leisure. I just want you to see the last one, right? Which one I leave as question marks. There's a key I haven't revealed yet, and I'm not going to reveal it till we go on to the second part of the talk, which is the case study. Okay. So I am in a company who will remain nameless, and there is a system, the current system they have, receives trades, enriches them, processes them, they're sent down to settlement. And the project rewrite was initiated when the current legacy system was taking 30 minutes for trades to process at market close. So if you're unfamiliar with financial markets, everybody sort of keeps their trades to the very end, so you can't tell their position, right? So when you do know their position, it's already market close, right? Multiple tickets were opened about this. So the clients were, lots of tickets in the system saying, look at this delay, 30 minutes to see that my trades were confirmed. It's terrible. And you can't just close a ticket where like, that's too bad, try tomorrow. Right? You have to give them some kind of leaf of hope or some sliver of hope, right? So it would say, hey, brand new system in development that's going to handle all of this. However, when I went to take over the project, there was no plan, no completion dates. There was a bunch of code, but the engineers that were on it had really no direction. They were just told, hey, go fix the problem. Oh yeah, and again, I have to make this second disclaimer, right? Because there's things that were done wrong and I was worried it will get attached to their name. It's from somewhere in my 30 years of experience. So now, the one thing I will say is I wish I had a talk like this that I could look back then. It ended up that I didn't have this sort of formal set that I kind of look at nowadays, but I seemed to follow it anyhow, so somewhat instinctually from all that I had seen. So what was the definition of success here? Well, I asked myself, is there a problem that will go away? Yes, there's a big problem. 30-minute wait times that like a bunch of people are complaining about. So that's my definition of success. I can say when I am done with this, that's what you will see. So I had a small team, and one of them was a long-time legacy system maintainer. He'd been there, I think, from college, but he was there 10 or 15 years. And this was great because he knew all about the current system. I had one new programmer. He was straight out of our program for taking people in from college. That was great. You know, he had lots of ideas. A middling guy, I don't mean middling ability. I just mean he was on the project maybe 3 years. Or in the group 3 years, and myself, right? I hadn't touched or looked at this system, but the area it was in, I was in maybe 3 years at the time. So I thought I had a good blend of experience, new blood or new ideas, and I figured I brought in the architectural experience. So first thing was analyzing the data flows through this system. As now, lots of times in a legacy system, you may have to go back and instrument the code, right? Because no one at the beginning when they wrote this figured they'd need to see these kind of metrics or data going through it. But in this case, I kind of struck out lucky in that there had been a directive from on high in management chain that everybody had to put their sort of statistical data of what was going on into the central repository. And because of that, I was able to just go in and look at. Now, no one I knew in my area was looking at this data, right? They said we did it, and then they forgot about it. But when I looked at what was going on, I seen that there was 3 sources of trades, but the ones that were having the problem were from 2 sources. One was direct from external clients sending trades in. The other one was from an order management system that was in-house and sending us a bunch of trades. So these were the 2 things that were getting all bottlenecked and giving me those big volumes. When I looked at the trades that were going into the system, I seen that we had a bunch of different types going in. Because I was able to look at the data, I could see that where's the biggest slice of this pie? Right, there's 54%, 53 point something, 54% was coming directly from clients, the biggest share of the data. There was also, 38% coming from the order management system. And then another 5 or 6% coming from a variety of areas, but really, really small volumes and really tricky trading stuff, right? But this allowed me to say, hey, looking at this data, I'm going to give myself some scope. I'm going to knock my scope down. I'm not going to deal with the 38% from the OMS, right? I'm going to go after just the biggest slice of the pie. And I will make the promise that I will come back on phase 2 and pick up the OMS trades. All right? So when I look at the direct trades, I can see that there's one user that's using this thing like crazy. And 78% of the volume is one client. Now, if I can get that client, this is going to be great. If I mess it up, it's going to be really bad, right? So quality. And then the other 4 users, if you drag them in, it was 85%. So you get 85% of this trade volume. It's plenty. And I can pull more and more in, right? If I've put the biggest guys on successfully, the smaller guys for these type of trades are going to be essentially just a mopping up task, all right? So that's one thing of looking at the composition of trades. Now, one thing I want to show you is the original architecture, which is pretty similar to what we had before. A trade comes in unfixed, gets pre-processed, gets a bunch of enrichment from different services. And then we go into the core handling, which looks at the current state, what's been asked to be done, mutates that state, saves it, and broadcasts it. And a response goes back out to the client whether it was successful or not. Now, when I looked at this model, look at the enrichment in there, right? That's serial. But when I looked at this, the enrichment phase was lagging, right? In other words, there was a bunch of operations being done serially in an arbitrary order. In other words, they weren't saying, let's do the easy ones first, or let's do the hard one first, or the ones most likely to fail, so that we get out earlier. It's just a random, hey, do 1, 2, 3, 4, n operations, single threaded. And when I looked, I was like, any hang up in this enrichment system is going to freeze this whole part of the system out. I went back and looked, and there were tickets about the system freezing up. No one had told me that when I was designing this thing, but I found it by looking at the data. All right. I then looked at the peak time analysis. I seen that we had stampeding volumes around 4 o'clock. And I also found something also very interesting, and there was throttling in there. And not intelligent throttling. It said that, look, that source C is very important and has a 1-minute timeout. And these 2 guys can overwhelm the system such that third source fails because of a timeout. And that is unacceptable. That's the premium. You can't mess with that. So someone put a big, huge throttle in there that said, hey, only let these guys do so many trades a second. All right. This was a throttle that was on all hours of the day. It didn't matter if there was anything going on the other system. It's just like a dumb throttle, right? And then the other thing was duplicate trades coming in, a lot of duplicate rejects, because when you're waiting and systems timed out, people are button mashing, do my trade. It's the end of the day. I'm very anxious about this thing getting done. And it was coming in over and over and over. Or they had a system that was just doing it over and over and over. We would only take one trade in eventually, but it went all through the enrichment phase before it got rejected, right? It went all through our heavy use piece before it got rejected. So I'm getting a good idea of where I need to go with my system, but there is a snag. And this snag is that there were trades where manual intervention could happen. All right. So the manual intervention happened in a completely different system that I'm going to say was a long time older part of the system, and they had no interest in helping me out. Right? They have their own problems, and it's all newfangled. So again, data analysis to the rescue. I went back and looked at the trades where we had manual intervention, ones that could be manual intervented and ones that actually were. And as I suspected, none of the large clients used manual processing, which makes sense. That's why I suspected it wouldn't be a problem, because if you got thousands and thousands of trades a second flowing through, you can't have a human go, oh, that looks good, or let me put a tick mark on that, right? So because of that, I was able to say these things are not in scope of my current project, again, narrowing that scope. And way down the line, when I have a lot of political capital, I can maybe strongly encourage this other group to give me what I need. All right. So in summary, I found that at the largest volume were simplest trades, and they were by relatively few clients. And that's where my whole system was chugging. So that's the efficient win that I targeted for phase 1. Now, they designed the system not by looking at the data, but by looking at the old system, coming up with the new system, right? And it doesn't matter. Here was the new system design, right? It's very close to the old one, except for instead of saving to a database and then having the core handling broadcast, there was a new API that was being pushed where you could save stuff to a database and people could subscribe to changes that go on in that database, right? So this is what they had. It doesn't address the enrichment problem. And by the way, you see these are ported processes that brought over. So they brought over a bunch of stuff I don't even think it worked, right? It's just the piece that we're looking at worked. So this is not the way to solve the problem. This is just doing the old thing with new technologies. So when I looked at the data, I seen that we need a hub and spoke model. And what I mean by that is this is what the new system architecture looked like. So you see at the top, all right, that we have a pre-process where the input comes in. It comes in into the hub, which is where the DB and distribution is. And then everybody is informed that something has come into the system. All the enrichers, which are reference data, external keys, permission, user data, all this stuff that needs to be enriched in the trade is done in parallel because we're all told, hey, new trade come in, you got to fill it up. But what also happens is the front-end distribution piece gets the original trade coming into the system with no processing done on it. So a skeleton trade goes right out to the app immediately, no matter what's going on in your system. All right, now, when the permissions get, populated in, then other people who are delegated to see that trade can see it. When reference data comes in, if you click on that trade and want to look at some individual details of security, it happens. But this all happens so fast in the normal happy track, no one would ever notice. The other thing is that, so that solves both of the problems of the enrichment lagging and multiple trades because you don't see anything on the screen. The other thing is the processes that are here could all be brought up multiply. So these, for instance, the reference data just pulled, right, and said, I will do this one here, or I will do that one here. So I didn't have to do it, but you could have created multiple processes. So, okay. So the new design is actually targeted at the problems we found by looking at how things flow through the current system. We lessened the dependencies, right? We upped the parallel, so all this stuff is going on in parallel. Fast display of the entered trades. It's scalable. In other words, if this thing goes up by a factor of, 5, I'll just bring up more of these enrichers, more instances of it. It'll be a few things to work out, but I brought up 2 instances of one of the things to show that could work. So it's scalable. And the technologies really were an afterthought. In other words, I thought about this, came up with, I need this to work like this, and then went and looked at my technologies. All right. And really, what I replaced the database and I think the inter-process communication, because that was handled by the database distribution API. That's all I changed. All right. Well, I also brought it to C++11, which was very whiz-bang back then. Like I was one of the few people working on it. Right. As I say, the design tackled real-world problems, right, based on my analysis of the shape of data and how the system handled it. So what about deliverables, charting progress, something I say we don't do enough of? Well, milestone 1, I want to see raw, unenriched trades showing up in the application. So as it comes in, hits my central hub, and goes back out, and I see it. All right, so how do I get to that milestone? Well, I'm going to replace all these ported legacy copies with properly designed code, because that thing is very spaghetti. But I'm going to replace the copies with well-designed code. All right, that's testable. And there's a bunch of them. Milestone 2, all the enrichment has been added in. What's the deliverables that comprise that milestone? Well, as the trades go through the app, hey, I've got the permissioning working. I can see when it goes through now, it shows up on multiple people's display, right? As I see the security data getting fleshed out. So you could see directly observable progress. And I could bring in any of the upper management and say, look at what we're doing right now. Look at the progression. Look at where we are. And by the way, let me pull you out my roadmap and show you where I am. They're a lot more confident on what's going on. We're somewhat amazed that you could actually do this structurally as well. All right. Milestone 3. So this wasn't on my original map because I thought I could just send my stuff to QA and QA would QA it. However, I was told you guys are not important enough to allocate resources and we're very busy. So we had to say, okay, that's the real world getting in here again, right? Hey, we're not giving you people, and we're certainly not designing a new way of testing your whole newfangled system. So what we did is we said, okay, there's a milestone to do with automation of all the manual tests for the legacy system. Turned out to be a godsend. I don't have to wait a week for my QA anymore. I only have to wait a couple of minutes, so my feedback loop is shortened. All right. By the way, when I did this, I was like, this is fantastic. They went back and did it for the old system. Right, so they put a whole bunch of this QA and had it run on the old system. The deliverables that comprise that is demonstration of each of the test sets that we identified in QA and the results showing. You can say, here, come down here and I'll show you how someone, creates, modifies and cancels a trade. I'll put one in where it's an invalid trade and it gets through a bit of the enrichment, but we kick it back. I can show all this functionality, directly observable. And then because we had this, another deliverable was added, which is regular on-demand QA, meaning I don't have to run it, right? It's on cron jobs as part of a PR process. PRs don't build. This thing doesn't work. Your code doesn't go anywhere. All right. Milestone 4, the system rolled out, enabled in production. The deliverables for that is an accepted production rollout plan and schedule. And then an actual, set of steps of how we're going to roll this out and turn clients on. I know that sounds a little crazy now when I hear it. Probably enabled clients would have been better than turning them on. Or maybe enabling them will sort of turn them on. All right. Now, the key to moving forwards. How am I doing on time? Not too bad. All right. Iterative adaptive improvement. So we had what I would call cutthroat design reviews. And what that means is scope gets checked on, right? You have design reviews, especially on new tasks, complete refactoring of code. I don't like to look at a PR, which is thousands of differences, and really what happens is you're doing something completely new, and the old thing doesn't really matter. All right, so we had these code reviews, and what I found, at least in the beginning, when I was sort of showing them how scope works, is that they had 50% of extra code in there. What happens if we need to plug in the new system directly into a part of this here? It's like, that will never happen and is out of our scope. What about in phase, 5, when we're doing this? I made this whole big template thing. Yeah, get rid of it, right? I need something that's narrow to what I need done with extensibility in mind. But I am not going to solve future problems now, because when I go to solve them, they probably have changed, or I'll get a better appreciation of the problem. So we built for now an extensibility for the future. Every conceivable problem, and I had this in another project, I had a manager who was very good at coming up with strange ways of things working, that it wasn't complete fantasy, they could actually happen, but I was like, the data shows this does not happen. And I am not about to derail my project for something that I don't have data that shows me it's needed. All right. So we had this cutthroat provisioning, right? You see cutthroat a lot, right? There's a lot of throat cutting in this thing. All right. So what about iteration? Well, design reviews were by the group. Code reviews were by at least 2 people. I often see this thing where 2 buddies sit together and approve each other's reviews, right? Leads to bad practices. So, and the team I have right now, it's like everybody take a look at the review. All right. Maybe down the line I'll be happier if only 2 or 3 are doing it. And something I always thought was common sense, but actually in one group I was in, I had to call a big meeting and show that we had not a backlog, we had PRs outstanding. I don't know, it was 30, 40. I'm talking about in progress, not on your backlog. Like, why do we have so many PRs? Because people love to write code and don't really like reviewing it. All right, like a cultural thing. So I had to change the culture and say, look, work that's started takes priority over work that's not started. Work that's in review takes priority of any work you're currently doing unless there's some special exception. We have some reason, like there's a production problem. And anything that's for re-review, especially. So in other words, it's gone through a round of review. It just needs the guy to say, yeah, you took care of all of my concerns. That's the most important of all. Because until a PR gets merged, you're just potentially useful work. Right? It hasn't been realized. So I have this idea of when work actually becomes real work, right? So we prioritized views over new work. So we kept a very short in progress line. Really, if there was more than 2 by the number of team members, I wanted to know why. Unit tests were a must for code acceptance. In other words, you give me a change and there's no accompanying test with it, I'm not even looking at your code. It gets kicked back. All right. And once you get that culture in, even my guys jumped on me one time. I inadvertently left out a test. And they're like, I don't care if you're the leader of the group. This is how it works. And, and it was. They were absolutely correct. And then with the QA system automation, that also gave us a system test, right? An integration test. And we could look at this, like I said, very quick loop. Found many problems, but we're easily able to say we've caught the problem, now we fix it. Or if some problem got away from us, the first thing we do is we build a test for the problem as far down the chain as we could, right? Found that we broke that test, and then we fixed the problem, right? We don't do that a lot. I think we should. What about observability? So basic health checking, yes, the process up, it fell over, some of its dependencies are up, but I had no telemetry, no how saturated am I? What's the latency? How is the traffic flowing through my system? And in fairness, this was it's at least over a decade ago, and no one was doing it. I know that sounds like an excuse. I guess it is, but there was no APIs for this. These days, it's great. Right? These days, you can say, look, I can put there's open source versions of these libraries. We have one in-house, and I can just put a few statements in my code, and now all of a sudden I have metrics and dashboards. I can see it all. We use Grafana, right? And I can see all the metrics of what's going on. It's like it's like a shuttle cockpit, right? And I have to do very little work with it. So I'm a big believer. But back then, I didn't have it. If I was in charge of this today, it would be something I'd be campaigning to put in. So I know where my system's starting to reach its limit, and I can, instead of having 2 years of client complaints, I can sort of make the pitch to do the fix now, so the clients never get to complain. All right, I preempt them. Successful rollout due to data analysis. I went through all of this, right? We got the whole thing. We had a few canaries, like the small. You don't just put, even as confident as you might be, you don't put the big client out first, right? You take a few smaller guys and you use them as sort of like going into the coal mine with the canary. If they fall over dead, you need more work. So here is the thing that almost killed everything off. After 8 months of work, successful code rollout to production, right? I had no clients. Why was that? Because I'm a sink of data. In other words, someone's got to direct stuff to me. So there's a group or area before me who's directing all the traffic to the old system. And I was like, listen, you got to sort of take this, be able to switch a portion of that traffic to me. Yeah, we're not interested. I don't know if there's a lack of glory, if it's, some other team, but they weren't interested in it at all. And this was sort of a bit frustrating, but I got lucky. And it was a very strange type of luck because in the interim 8 months, the times had only gone up. Volumes had gone up, the times had gone up. 40 minutes plus. And the largest client complained to senior management directly. And when I mean senior, I mean right the way up the top of the chain. And said, why are we still dealing with 40-minute plus waits after a couple of years of talking to you guys about this? I'm being told you're developing a system. So they're saying, hey, what's going on? I'm like, I'm ready to rock. I'm down here ready to go. Well, what's your problem? Over here. And they very, very quickly made it's like about 2 days, maybe 3 days of changes, right? Did it almost instantaneously to start it on it. I know I heard about it Monday. I was like, you're ready to go Wednesday. I was like, that's nice. Right, so wait times that increased. That's what I just told you about. So we did the first client or two, went successful, brought in the big clients. All the bottleneck disappeared, right? So we had under a minute, I don't even know what it was, but that whole market volume, there was no lag as far as the customer was concerned, right? It was a really nice email, went around far and wide, you know, these guys are great. Look at the new system. We're all very happy. And I had made a promise. The OMS trades will be picked up in the next iteration. All right. Now, I kind of held to that promise because I left the group. Right? I said my work here is done. There's other places need my attention more than here. And the new guy who took it over, I showed him and explained what had been done. And he picked them up in the next iteration. Right? So they got done, I think it was another 3 months or something like this. But he got them done. And, you know, I said to him, it's years later, like it's a really long time later, but I'm still friends with him. And I went to him like, does it need a rewrite? It's been in there quite a few years. Does it need a rewrite? He's like, it's a well-behaved system. I don't really do much to it, though I have noticed lately more PRs going against it. I believe they're now trying to make that. So I replaced a part of the system. I think they want to upgrade that to be more of the full system because it's proven itself out. I would be much more confident in saying everything is okay if I had metrics on it. If I could say, look, the peak loads on this, the latencies on this, they're still fine. They're where I left them. Right? And that's why you want telemetry. So let's just recap. Keys to redesigning a legacy system is you need to have a definite measure of success. And you need to know knowledge about the old system. The key to having a set of, and you need requirements. I don't mean a big 40-page document. I mean, you need a bullet points of what your requirements are going to be. You analyze how the data flows through your system. You locate the problem. Then you design solutions. People skip this step. And then because I have done that, I'll be able to produce a design. But again, the technologies are uninteresting to me in the beginning. When I look at a system first, I look at the components, how they interact, not what's underneath the hood. All right, and underlying technology replacement is usually not the answer. I say usually because where I am now, it is actually the answer. Right, using Linux gives me much less latency than the other ones. Charting progress, stage via deliverables. So your milestones has a bunch of deliverables. Those deliverables are done by, if you're in sprints, with sprints and tasks that are not big. If they get, like I have my current team, and I was sizing out, like the 1 pointer, 1, 2, 3, 5, it's Fibonacci, 8. And we get up to 13, and I was using the Scrum guy, I said, I don't need a 13. I said, what do you mean you don't need a 13? I said, if I ever go to 13, I need to break the task down. I don't want that lack of resolution, like go out there and come back in 2 weeks and tell me if you found out anything. Keep moving forwards, struggle to adhere to your design goals and vision. Beware the real world is messy, we'll try and corrupt that. But terminal mismatch means your design did not account for all of reality. And you have to account for it. But do it sensibly. When you want to deliver the product, iteration is the key. The feedback loops, that is your productivity killer. Scope creep and iterations that take a long time. And then if you have meaningful metrics and alarms, it's just a great, I'm on a system today, I can just look at stuff and see, hey, here's what's going on. I can understand the bad points and the good points and what needs to be looked at. And then for a successful rollout, if you're moving from an old system to a new system, bring the big volumes first. They're generally easy to handle. You just have to be intelligent in how you parse it out. No, this was question marks the last time. The key intangible, and you shouldn't rely on this. You should rely on this as little as possible. But I've talked to a lot of guys who have been in these projects, and they say there's an element of luck, right? Oh, this just happened to be gone at this time, so I was kind of lucky. And I got luck there because like people complained even more bitterly than they had before. That is the end of this presentation. So if anyone has questions, we have 5 minutes. Okay. All right, well, I hope you found that worthwhile. I think in our industry, and I'm going to make a broad sweeping comment here, in our industry, we give you lots of tools. That's like a toolbox full of spanners and screwdrivers and even electric drills. So look at all this really neat stuff that's in C++20. Look at the stuff that I can use here in, I don't know, Python and doing all this kind of stuff. But I think what we do a bad job of is teaching you how to put them tools together in a way that delivers product, right? We are saying, it's like I say, like here's a bunch of engine parts and here's a bunch of screwdrivers and spanners. Give me an engine, right? We don't teach people how to properly engineer and how to properly deliver product, because the redesign in the code, like I say, is potentially useful. It's only when it gets to production that the clients get that value. Hi, Bob, you had a question.
Yeah, actually, you echoed something I've been screaming about for years, and that's the importance of requirements and understanding what it is you're trying to build. Can you speak to, do you do like traceability between requirements and test cases to validate that you're building what you say you're going to build? Do you do that formally, or?
I don't have a formal process per se, right? So, I mean, even Agile, I only use it as much as benefits me. I mean, it's got to work for me. I don't have it as a monkey on my back or something. And I find that the structured systems that you put in place they don't address everything. So what you're trying to do is say, here's the foundation, and then that will go off. And in some of the work I did here, the guys went off and said, look, we want to change it to do this way, to do things this way instead. I was like, well, that's interesting. How do you justify that? Well, and they were used to me in that you can't just say I want it. So they'd say, look, here's what we're doing, and this we think is better. Okay, what does the group think? We have consensus from the group, then let's adopt that. We can always roll it back. But as far as formally saying that was more like the waterfall model, where we used to say, before you write a lick of code, I have to get my every requirement down.
I guess what I was thinking of more of is not that per se, but you've got some bullet points, which you said before, which represent your requirements, the things that you've committed to. Got a bunch of test cases. Do you make sure that your test cases indeed verify that you've met all of your requirements?
No, so I make sure the design meets my requirements, and then the testing is to verify that design works.
Okay, so transitively.
Yeah, so the question was, do I map directly from my requirements to test cases? So I don't write all the test cases first on some shell and then start designing sort of to satisfy these cases. I know that is a way of doing it, but what I do is I'll figure out requirements from what's really going on in the system. Then I come up with a design and set of deliverables. And then as you design that, to keep the quality, and that's important, the quality of that testing, right, is going to determine how reliable that product is when it ships, and for the lifetime of that. So I'm not just trying to get it out the door. It gets into production. Right, it's in there a week, and then I say I'm out of this group because I know some tidal wave's coming. Right? You've got to think of the long term, that this system will be I know it's over a decade, I think, since this system, I wrote it. I knew when I put it in, it wasn't going away anytime soon. All right. So I think we're out of time. Thanks everybody for coming here. I hope you learned.